Hello, in this video we are working through example 9 in chapter 4 where we're talking about discrete random variables. And in this example we're going to use the notation that was just introduced to us in the notes with this p of x less than or greater than some sort of notation. So this we would read as the probability that x is less than 7. X is the value that our random variable takes on. So we are trying to figure out the probability that our random variable is going to be less than 7. Now, if you recall, our random variable, our binomial random variable, only takes on whole number values, 0, 1, 2, 3, 4, 5, 6, 7, and so on. So if x is less than 7, strictly less than 7, it means it's not going to equal 7, but there's nothing in between 6 and 7 that it could equal, so we actually could write this as just x less than 6. So in other words, the probability that x is less than 7 is the same thing as the probability that x is less than or equal to 6. Now the reason why we want to be able to rewrite it like this is when we start talking about calculating probabilities using a calculator, we need to have it in this less than or equal to format. So let's consider these other two then, keeping in mind that in order to put it into a calculator, we always need our probabilities as x less than or equal to something. If we have something like this, the probability that x is greater than 6, so that means that we are considering the values for x that are 7, 8, 9, 10, and so on, up to whatever n is. Well, the only two possibilities for x is that it either is greater than 6 or it's less than or equal to 6. And those two possibilities, the probability of x greater than 6 and the probability of x less than or equal to 6, if we were to add them together, it must be equal to 1 because that encompasses all of the possibilities. So then we could rearrange this. We could subtract this from both sides, which would end up moving it over to the right. So we end up getting what we need, which is the probability that x is greater than 6 is equal to 1 minus the probability that x is less than or equal to 6. Okay, one more example here, just a little bit more complicated. The probability that x is greater than or equal to 8. Well, the problem here is that we are actually including the endpoint here. So we can't just flip it to 1 minus the probability that x is less than or equal to 8 because that equality can't be contained in both. So that's not what we need here. But we can make it into a strict inequality. So the probability that x is greater than or equal to 8 is equal to 1 minus the probability that x is strictly less than 8, using a similar reasoning to what we did up here in number 2. But now, remember, for a calculator, we always need these written as less than or equal to. So x less than 8, using something similar to what we did in number 1, x less than 8 is going to be equal to the probability that x is less than or equal to 7. So this becomes 1 minus the probability that x is less than or equal to 7, and 7 is what we can write in our inequality, or in our statement there to complete it. Now, one thing I do want to note here with these inequalities is that these statements, they hold only for discrete random variables. And even more particularly than that, discrete random variables that take on whole number values.